So let's talk about torque. Now, when you hear of torque, the first thing that comes to your mind should be a couple force. I mean, two coupled force. And the other thing that should come to your mind is it creates a turning effect. So when I want to bend something with just one of my hand, I turn it. If I want to like increase the volume or reduce the volume of my Zealot speaker or my FM radio, I give it a turning effect. That's torque. I want to turn the handle of a door. That's torque. So the first thing you should know about torque is the formula of torque. Now, what is the formula of torque? Torque. Okay, let's say you should know that torque is a vector quantity, not a scalar quantity. But it has magnitude, that has direction. That is different between torque and work. Work is a scalar quantity, while torque is a vector quantity. You should know that torque is R cross F. You should know this. Number one thing is that torque is R cross F. Torque is never F cross R. Maybe you would have known that torque is force times distance, same as formula for work, but you should never mistake it and never confuse it with work, because work is scalar while torque is vector. So torque is R cross F, where this R is the perpendicular distance, and F is the force, right? So you should know this. And the other formula for torque you should know, since you know this already, you should know that in vector, anything R cross F, A cross B is AB sine theta. So since this R cross F, this will be R F sine theta, where the sine theta belongs to the F, not the R. So this R F sine theta, because A cross B is AB sine theta, so R cross F will be R F sine theta. The angle belongs to the force. So you should also know there is also another formula for torque. So this is number one, this is number two. There's also another formula for torque. The other formula for torque is m r square alpha. Now there's a way they derived this. There's a way they derived this. Also derived it from this formula, but we'll not be going there today because you just need to know the formula, and that's all. Derivation is later things. So this m here is mass, the r here is still the distance, while the alpha here is angular acceleration. So you should know that the alpha here is angular acceleration. Now, from this formula, that we know that torque is mr square alpha. Then we can also say torque is mr square. That's already giving you the formula for moment of inertia. You can see it's mr square. That's the same as the moment of inertia. That's I alpha. So these are the four formulas you need to know about torque. You should know torque: R cross F, R sin theta, mr square alpha, and I alpha. They're very easy to memorize. If you know this, you know this. If you know this, you know this. If you don't even know this because of it's long, just know I alpha. I know I is mr square, and you get back to your formula. So that's that on that. Okay, you should also know the unit for torque. The unit of torque is Newton meter. You know, torque is a Newton meter, just like normal unit for work, force and distance, but they are different. Work is scalar, torque is vector. So the unit is also Newton meter. So let's go into another. So there's this question in the slide. It will be in the description of the video. They said a torque 32 Newton meter causes a wheel to rotate, giving it an angular acceleration of 25 rad per second squared. And they asked us to find the rotational inertia. You should know another name for moment of inertia is rotational inertia. So to find this, they gave us torque, they gave us angular acceleration. They say to find moment of inertia is as easy as pi. So that will be T equal to I alpha. T is given to be 32. Can you see the board? Yeah, so T is given to be 32. I is given to be what we are looking for. And the angular acceleration is 25, right? So I is just going to be 32 over 25 when we divide both sides by 25. So that's going to give us So that's going to give us since so I will be 32 divided by 25, 32 divided by 25. That's 1.28, 1.28 kilogram meter squared. 1.28 kilogram meter squared. So that's the answer for that question. That's the answer for that question. So these are the solve question on talk when they give you the moment inertia, they give you the angular acceleration. This is the formula. They can ask you to find any of the unknowns. So this is the formula I should use, and it's as straightforward as that. Yeah. So just like we have linear momentum, we also have angular momentum. So the formula, the first thing you should know that angular momentum is represented by L, and angular momentum is given by this formula. L is equal to IW, where the I here is the moment of inertia, and the W here is angular velocity. So yeah, this is all about angular momentum that you should know. So let's just solve one question from the slide. And the thing you should know about the this second part of if it's 101 is that these stuffs are not very difficult. The most difficult part is just mechanics. Mechanics, yeah, mechanics. Any kind of question can come out of mechanics and it's easy to bang. But questions like all these ones, simple harmonic motion. Okay, simple harmonic motion, yeah, some are tricky. But questions like these are not very difficult. Questions like vectors are not very difficult if you understand. But you see mechanics, you can understand it and another question will come out and you bang it. So yeah, angular momentum is a vector quantity. You should know that. So there's this question in your slide. They said a sphere, then they gave the radius of the sphere. It rotated through the center. Rotated through the center. So that one is not giving us problem. We already know it's rotated through the center. So just use the moment of inertia just like that. They say it's rotated distance away from the center. And we are going to use parallel axis theorem. But just rotated through the center. The question is in the description below this video. So to get access, check the questions. Then you can see what I'm solving. So they gave us the mass of the sphere to be 15 kilogram. They gave us the angular velocity as it was rotating to be 3 rad per second. So they said to find the angular momentum. What's the formula for angular momentum? Formula for angular momentum L is hello. So formula for angular momentum L is I W, right? So what is how do we go about this? This moment of inertia. Our moment of inertia for sphere I, we are giving W already to be 3, so we don't have a problem with that. But the problem now is solving for I. So for sphere is 2 over 5 mr square, right? So 2 over 5 mr square. So that will be 2 over 5 times the mass is 15, and the radius is 0.5 by 0.5 squared. So when we do this 0.5 squared, so let's just do this. So let's just calculate this as 2 divided by 5, 15. So all this is just 1.5 kilogram meter square. So that's the moment of inertia. We've calculated the moment of inertia to be 1.5 meter square. So let's just go direct. That's 1.5 times our value for angular velocity is 3. So 1.5 times 3, that's just 4.5. So that will be 4.5. So our angular momentum is 4.5. So what's the formula for what's the unit for angular momentum? So the unit for angular momentum will just be kilogram meter square per second. So that's our unit for angular momentum. You need to know the unit for all this stuff for torque, angular momentum, in a moment of inertia. You need to know you need to know all this stuff. And don't confuse inertia to moment of inertia. Moment of inertia is when we are considering all these rotating bodies, rigid bodies. But inertia in our normal inertia is the unwillingness to move and the unwillingness to stop moving. As in momentum. After that, have I? Okay, I'm not. Okay, so let's just okay. So these are to solve this the questions on this. So, So is there after angular momentum? These things are just easy. They are just formulas. That's it. They are just formulas. Just know the formulas, and that's all. If you want to know how to derive them, yes.